So in section 1.1, we're going to talk a little bit about inductive and deductive reasoning. It's ways to make valid conclusions on what's happening and what we know and what we can decide because of that. So first we'll start off with inductive reasoning. Inductive reasoning is when you are making a conclusion based on a limited collection of specific observations. Sometimes that's as basic as following a pattern. Okay, some examples of that are right here. Use inductive reasoning to find the next item. We can look at this pattern. It looks like what I'm seeing here is this is times 2, 4 times 3, 12 times 4, 48 times 5 is 240. So in order to do our next one, we're going to need 240 times 6. 1200, 1440. I did that arithmetic, right? So it's just a matter of looking for that pattern and seeing what's happening. Sometimes in geometry, it's a pattern of design. Okay, think of these as maybe a bunch of toothpicks on there, where really each little one is adding a row and a column. If we had to do another one, we would add, instead of redoing the whole thing, I'm just going to add to this one. Yeah, and we could do that. We could talk about these in terms of the number of sticks in each one. This one has 4. This one is 4, 5, 6, 7, 8, 9, 10. So we have 10, 11, 12, 13, 14, 15, 16, 17, 18. We could come up with a pattern there. 28, 40, and then the next one, 41, 42, 43, 44, 45, 46, 47, 49, 54. We might be able to do a pattern then with those numbers. It looks like plus 6, plus 8, plus 10, plus 12, plus 14. And by that, if I had to do yet one more pattern of this with even a bigger square, I'm thinking that in order to do that, if I'm using toothpicks or whatever, just the number of lines, it's going to take me, I'm going to need 70 little 6 to do it if I follow that pattern of the next even number. Okay, for the sake of time, I'm going to kind of skip part C here. And it might be this pattern looks like a subtraction pattern. Minus 6, minus 6, minus 6. It's going to take us to negative 14 for our next element in that sequence. So in your textbook, you can look at the definitions here as well. This one's on page 3. An axiomatic system, then, it consists of 4 parts. Undefined terms, that's really just your starting point. Okay, we can't actually define absolutely everything. Sometimes it's like, all right, this is where we're at. It's impossible to just truly define every term. Okay, definitions are formed with words. Words have meaning. A definition are statements that give meaning to new terms. Okay, statements that give meaning to new terms. And then axioms or postulates are statements about undefined terms that are just accepted as true without actual formal proof. So accepted as true without formal proof. And then all of that, we can use all of those things put together to come up with theorems. It's a statement that we can prove using definitions and postulates and axioms. Okay. Statements that can be proved proven using definitions and axioms, postulates. Okay, so deductive reasoning, then, is a conclusion that's based on a collection of generally accepted assumptions. So there's a couple of different types. You talk about logical arguments here. Is it okay to make this conclusion based on what we know? So there's two different types. One would be called the law of detachment. I like looking at this a little bit this way. Detachment, think about pulling things apart. Okay, if your premise is telling you, well, if P is true, then Q is true. You have another premise. So premise, oops, typo. Another premise there that's maybe specific to P, then we can make a conclusion that's specific to Q. For example, okay, example here, why is my, oops, there we go. If a student at Niles High has room 303 as his or her homeroom, then that student is a freshman. Well, so there's really to think about the if-then part of it. There's two parts to this. So if they have 303 as their homeroom, then that student is a freshman. Well, Joe Jacobs at Niles High has 303 for homeroom. So this is not just any old student, but specifically Joe Jacobs. So then our conclusion is that specifically Joe Jacobs must be a freshman. Okay, so it's really one, what we call if-then statement that we can pull apart into two statements, detach them, okay, in more of a specific case situation. But then there's a law of syllogism that is a little different than that, where we have a couple of premises that we can then make a conclusion, follow the pattern here. If P leads us to Q, and Q leads us to R, my conclusion could be, well, if I'm going to start at P, eventually I'm going to end up at R. Okay. So, for example, if you don't do your homework, so not doing our homework means we're not going to be given permission to go out. Okay, so this is like our P and our Q. Okay, well, if we aren't given permission to go out, so notice that's the same. It's talking about being able to go out. Then that's going to mean we miss the movie. That's our R. So because these two things match, the end of the first one matches the beginning of the second one. See that? End of the first one matches the beginning of the second one. Our conclusion is, if you don't do your homework, then you're going to miss the movie. Okay, so it goes straight from P to R. So just a couple of examples here. Is it valid or invalid? If my dog does not bark all night, I will give him a treat. If I give my dog a treat, he will wag his tail. Okay, so does it follow the pattern? So the thing to look for here is that stuff matches. So that should mean that I can go straight from beginning. If my dog does not bark all night, to the end, he will wag his tail. So that one is valid. Okay, that's a syllogism. That's a valid law of syllogism. Okay. Premise. All school buses stop at railroad crossings. Another premise. If a vehicle stopped at the Santa Fe, there is a vehicle stopped at the Santa Fe railroad crossing. Conclusion. That vehicle must be a school bus. That is not valid. Okay, it doesn't follow that pattern correctly. Just because it's stopped doesn't mean it's a school bus. It could be one truck with the gas tanks that has to stop. Other sorts of things. It could be any other type of vehicle that stops at railroad crossings. You just have to be careful. It's kind of like that detachment we talked about, but it's the wrong direction. We have to talk about what stopped first. If a polygon has 3 sides, then it is a triangle. If a figure is a triangle, then the sum of its measures of its interior angles is 180. So again, notice in our 2 premises, notice how that matches. So look what happens to this if a polygon has 3 sides. Then, can I get other colors? We'll try something light. I think it'll work. Then the sum of its measures is 180, which matches with this. Okay? So you got to be looking for that. Now, premise. If it is Christmas, Sylvia will buy. Oh, sorry. Actually, it's valid. This one then is syllogism. If it is Christmas, Sylvia's going to get her mom a present. If it is Christmas, she's going to get her brother a present. So, conclusion. If she gets her mom a present, then she will also get her brother a present. Okay? Again, that's not valid. That is not valid. It could be Mother's Day. She got her mom a present. Doesn't mean she'll get her brother a present. The stuff doesn't match. The end of the first one doesn't match the beginning of the second one. So that it's not gonna, we're not going to make that valid conclusion. So just making a couple of conclusions here. If Mike visits Alabama, he will spend a day in Montgomery. If he spends a day in Montgomery, he will visit the museum. Again, the end of this one matches the beginning of that one. If Mike visits Alabama, then he will visit the museum. And that would be syllogism. Okay, if it is the 4th of July, there will be a parade. If there's a parade, Maria will go to the parade. Again, beginning of the second one there matches up to the end of that first one if it is the 4th of July. Oops, sorry. If it is the 4th of July, then Maria will go to the parade. One at a time here. Okay, valid syllogism. If you run every day, you will get healthier. If you run every day, you will get faster. Those 2 things may very well be true, but we cannot make a valid conclusion. Well, valid conclusion. Okay, we don't have that matching up. One more. All football players wear helmets. Sarah wears a helmet. Is the valid conclusion going to be that Sarah is a football player? No. She could be wearing a helmet because she's riding her bike. She could be wearing a helmet for various reasons. There's lots of reasons. Again, no valid conclusion. Okay, so just, take a look at, be careful on what you can and cannot do as far as making conclusions. Take some time to look over your textbook in this section as well, and we will take a look at some of those problems.